Let us start this lecture with a thought process by Johann Rockström. He says, to reduce the risk of a global environment catastrophe and to avoid reversing the course of human progress, the world must urgently bend the curves of global emissions away from the fossil fuels. Now, this is a very great statement and which really we need to look at, but however, we need to also look at how to devise the combustion system such that it will be meeting our need while polluting the air the least. In the last lecture, we discussed about how to control the COX emission and also how to control the SOx emission level in the combustion system. And today, we will be looking at very briefly NOx emission control and also the particulate matter control. So, NOx emission control, if you look at, is very important because of fact that it causes a lot of health issues as we had discussed, particularly the pharynx and then nostrils and other parts get affected very easily. Nitrogen in atmosphere forms 8 different oxides during the combustion. However, we will be only considering 3 of them as they are important, and those are nitric oxide, nitrous oxide and nitrogen dioxide. So, these 3 will be considering, and is NO harmful to health than NO2? Certainly no, rather NO2, that is nitrogen dioxide, is more harmful as compared to the nitric oxide. By what reaction NO, NO2 are formed? N2 will be reacting with the oxygen that is available in air and will be leading to the 2 moles of NO. Of course, that will be occurring at a high temperature, and 2 moles of NO can react with oxygen to form 2 NO2, that is nitrogen dioxide. And for any chemical reaction, the Gibbs free energy attains a minimum value for a particular temperature and pressure that we have already dealt with at length. Just to again recapture the essence what we had learned, that is ln Kp is equal to minus delta G T divided by RUT, and Kp is the equilibrium constant and delta G naught is basically standard Gibbs free energy change that is occur during the chemical reaction at equilibrium. And if you do this computation at different temperature, which is being shown here 300, 500, 1000, 1500, 2000 and 2500 Kelvin, you can see that NO that is in ppm, ppm basically parts per million at 79% of nitrogen and 21% of oxygen corresponding to air. And this is at 300 Kelvin, this is a very low value, that is 3.1 10 power to minus 10. So, also the NO2, which is also low, but little bit more than the NO. And as the temperature increases, this is NO values are increasing at rapidly, and a very higher values at 2500 is 24,000 ppm. Of course, the NO2 also increasing trend, that means with temperature increase, with temperature this NO2 increases with temperature, and so also NO level. That means, it is basically dependent on temperature what it says from the equilibrium point of view, and therefore, one can get the clue that NOx emission can be reduced by decreasing the temperature, and particularly when we are using the air as a medium. So, NOx formations mechanism one can think of as Zeldovich mechanism, and there is another way of fuel mechanism and the Fenimore mechanism. The thermal NO is basically comes from the Zeldovich, who was proposed that one, and thermal NOx are formed by simple heating of oxygen and nitrogen, as I had told earlier, and so that this is basically it is O plus N2 going to the NO plus N, and the radical N is being formed in this reaction, can react with the oxygen to form NO. And these two reaction is basically given by in the beginning or proposed by the Zeldovich. Therefore, this is known as Zeldovich mechanism. But later on people gave another reaction which is added to the Zeldovich mechanism, that is N is reacting with OH going to the NO plus H, and this is three together is known as thermal mechanism. For NO formation, and thermal NO contribution is quite low till it attains the temperature of around 1300 Kelvin, but beyond which it increases rapidly. That we will see by looking at how it is. But before that, let us look at the prompt mechanism, refers to the NOx formation which are formed very quickly by interaction of active hydrocarbon species, particularly derived from the fuel with nitrogen and oxygen. So, they are not generally observed in the flames of non-hydrocarbon flames, but if the hydrocarbons are there, then naturally the Fenimore or the prompt mechanism will be there. They cannot be formed by just heating the hydrogen with oxygen that we had seen earlier, and which is basically different than Fenimore mechanism, and that is the basically the thermal mechanism. During initial phase of combustion, the radicals with the carbon atom react with nitrogen to produce the N. As per the following reaction, let us say CH is a radical which will be reacting with nitrogen and forming the SCN, and again the radical N or the N atom, and this reaction is the main path which indicates the rate at which the radical N is formed. And the radical N can also be formed by the following reaction. C will be reacting with N2, getting into product of Cn and N, and when equivalence ratio is less than 1.2, the SCN can be converted into as per the following reactions, that is SCN is reacting with O getting into NCO plus N, and there is another reaction NCO is reacting with H going to the NH plus CO. Keep in mind that during hydrocarbon reaction there will be several radicals like O and H and CH will be formed. As a result, the NCO is reacting with H going in getting into the product of NH plus CO. keep that all these reactions are both forward and backward depending on the temperature and pressure, it will be taking the different path. NH will be reacting with H getting into N plus hydrogen, and N can be also reacting with OH radical getting into NO plus H. That means, any path it can take, particularly when equivalence ratio is less than 1.2. So, in this case what we had seen, we are basically seen how this SCN will be converted into NO following this step of reactions. So, NTO in intermediate mechanism, we can see that particularly when the fuel lean condition, that phi is less than 0.8 at low temperature condition, O will be reacting, the radical O will be reacting with nitrogen, of course, under third body, M is the third body, and which will be occurring at little bit higher pressure, getting into the N2O and then M, and this third body can be anything, can be nitrogen, can be any other stable species which is not participating in the reaction. And H can be reacting with N2O, again a third body, and getting into NO plus NH, and O will be reacting with N2O into the NO plus NO. And keep in mind that this will be intermediate species, which is that means both N2O are formed depending on the situation, and also the NO being formed in the process. So, the intermediate like means N2O is the key for the formation of NO in this method. So, if you look at the NOx emission, particularly we are talking about NO now, and with the various temperature, you can see that the prompt NO is not changing with respect to temperature, and it is having a very low values, whereas the fuel NO depending on of course the condition, whether it is a rich condition and also whether it is a hydrocarbon fuel or not, because for hydrocarbon fuel that will be very important one, right. And this will be having certain values, whereas the thermal NO remains almost constant till maybe 1250 you can say, and it picks up rather I would say that till 1200 it remains constant, and it peaks slowly, but it becomes faster beyond the 1300. If you look at 1300, it really increases at a faster rate. So, therefore, the and which is quite a huge value as compared to other one, and the radical N can react with oxygen to form NO and SCN, that we had already seen in the Fenimore method. And the thermal NO contribution is low till the 1300, and beyond which it increases rapidly. Several techniques are being devised to control NOx in the combustion, and which we will be discussing them in a very brief manner, rather very few method I will be discussing because of due to the paucity of time. And NOx control technology, if you look at, can be broadly divided into two categories. One is combustion modification, other is post combustion controls. Post combustion control is selective catalytic reduction, because various catalysts being developed and used such that you can really control the NOx. And there is also selective non catalytic reduction, and in which the various chemicals and being used such as urea or methanol can be injected to the product gases, such that you can reduce the NOx, and so also the urea being used to reduce the NOx in the post combustion process. And beside this, ammonia is also being injected for certain kind of combustion system to reduce the NOx emission before you really let the flue gases to enter into the atmosphere. And this we are not going to discuss the post combustion control methods, rather we will be discussing combustion modification method. Only two of them will be discussing combustion modification method. So, if you look at the combustion modification method, there are several methods which have been really developed over the years, and some of more are also being developed. If you look at the one method is the low excess air method. One can really use it, and which is very easier to do that. And beside this, the stage combustion method can be divided into burners out of service, and then because some of the burners you may not use it, other is overfire the air, and other is bias firing, and which we will be not discussing, but however we will be discussing about the low excess air method. We will be discussing about this, and there is a re-burn method. That means, once you burn it and then again you can basically burn in such that it will be NOx can be reduced. And there is another way of that, you can design the burner such that the low NOx will be produced, and again there we use the similar technique, like that is the stage air one can think of, and other is the stage fuel, and there is a fiber burner which is coming up that can be operated at a low temperature. And there is also the lot of interest to use the oxygen combustion, or such that you can reduce the NOx. One way is that you can enrich the air with the oxygen addition, lot of work is going on. Beside this, another way is that which is being used for particularly big power plants and then engines also, that is temperature reduction, because that is the crux of the NOx formations, that is the thermal NO contributes more amount of NO as compared to the prompt or the fuel NO. So, one way of is that reduce the air preheating, which is being done basically to enhance the combustion efficiency and also the reduce the CO emission level. Another way is that water injection, which can reduce the temperature drastically, and some people also use the alcohol injections, so that you can add some fuel or the calorific value, at the same time you will be using certain amount of energy for vaporization of the alcohol. And there is another method which is being used nowadays very much, and flue gas recirculation, circulate the flue gas into the combustion chamber, so that will be NOx can be reduced. So, we will be basically discussing about the stage air and maybe some of the flue gas recirculation and some other method we will be discussing, not all the things because of paucity of time. Let us look at low excess air. Boiler and furnaces, as I told earlier, are operated with excess air, because of fact that the fuel has to be burnt completely to have the higher combustion efficiency and low level of carbon monoxide, and that is why a large amount of excess air than the stoichiometry is being used routinely. And of course, the advantages is that the combustion is operating with excess air always advantageous. Certainly no, because although the combustion efficiency gets enhanced, but however it leads to a more NOx formation, which is a nuisance so far air pollution is concerned. So, let us look at how this NOx formation is getting increased with the excess air. So, if it is excess air is very less, So, you can find that basically the around NOx ppm 100, but it as the excess air increases with the maybe from something 1 or 2% to 25%, there is a 5 times of the NOx formation. The 5 times increase in NOx gases, NOx emission. So, therefore, it is a very important to reduce the excess air consumption during the combustion. If you will use the less amount of excess air, then naturally what will happen, there will be drop in the combustion efficiency, and there will be also increase in CO level, and however, NOx formation will be higher. But what we need, that we will have to make a concerted effort to optimize the excess air, such that we will have a reasonable amount of CO formation and also the reasonable combustion efficiency, and with a reduction of NOx emission. So, that we will have to keep in mind. Let us look at stage combustion system, and in the stage combustion, as I told, that in this case the fuel is being used, and this is the air which is coming over in this case and mixing, and this is the flame stabilizer which is used to recirculate, create a recirculation zone, such that it will stabilize the flame. And you can use the excess amount of air, but however, the air is known as, this is known as primary air, and there is also another secondary air which is being injected in such a way that it can cool the flame, and some combustion can also take place, because generally this will be rich flame or rich condition, fuel rich flame will be there, and there will be some carbon monoxide which will be there, which needs to have secondary air, so that combustion will be taking place. In this case, the carbon dioxide is being reduced, at the same time the temperature will be low, such that the NOx formation will be also being reduced. So, this is most effective method to control NOx emission level, because as I told earlier, the upstream burner operates in the fuel rich mode, and the downstream it operates on the fuel lean conditions, and when the additional air is added to the downstream of burning fuel, and NOx emission can be reduced by 10 to 40%. And let us now look at flame cooling, and the thermal NO can be controlled by reducing the temperature of the gas which is being produced. How to achieve the temperature reduction is the question. So, this can be by reducing the preheating of air which is entering into the combustion chamber. Let us look at like a combustion chamber in which the air is coming, this is your air, and it can be generally being preheated to reduce the CO emission level and also the enhance the combustion efficiency. However, you can reduce this preheating air temperature. And another way is that water or the steam being injected out in this in the combustor, you will have to injecting water or the steam, such that that water will be evaporated, and then that heat will be taken from the combustion product, such that the temperature will be lowered down, and steam also will be reacting with the CO and will be converting into the basically carbon dioxide. As a result, you can reduce both the CO and also the NOx emission level. There is another way is the EGR, the exhaust gas recirculation, which is the product may be containing the CO and other unburnt hydrocarbons, and which can be recirculated, such that when it will be recirculated and mixed with air and getting into again burnt, and such that the CO will be converted into carbon dioxide, unburnt hydrocarbon can be converted into carbon dioxide. As a result, the combustion efficiency will be increasing and CO USC will be reducing, and NOx is also getting reduced, because of when you are adding that lot of some nitrogen gases will be passing through that, and it will be lowering the temperature, because temperature is being lowered here. And this is a very effective method of reducing the NOx emission and enhancing the combustion efficiency while reducing the CO and USC. Therefore, it is being used profusely in practical combustion systems. And these three methods reduce basically the peak temperature of the combustion products, and as a result the NOx being one. And of course, some of these methods may lead to the higher emission level of CO one has to look at, and people have found that 10 to 15% reduction in NO can be achieved by these methods. So, therefore, these are being used in particularly the exhaust gas recirculation method is used in practical application. So, now let us look at how the particulates are formed in the combustion system, and particulates are basically formed due to oxidation of inorganic material in the fuels. Besides, the soot are being formed in the hydrocarbon fuels and also the coal due to the fuel rich condition, as we had discussed earlier. And what are the sources of particulate matter? Basically, coal, biomass combustion result in particulate emissions like ash and other inorganic materials convert into oxides. And of course, even in gaseous fuel and liquid fuel you can get also the soot particulates, which is has to be avoided, and combustion of low grade oil also generates particulate matters. And these particulates are generally less than 10 micron size. It can be having certain range, and these has to be also removed. But question is how to remove these particulate matters. Long bag house filters and electrostatic precipitator can be used or are being used rather to remove them, in particular in power plants. And in case of electrostatic precipitator, the charge of particles in the flue gas being undertaken, and then these charged particles are made to attach to the wall by passing through strong electric fields, and once these particulates are being attached, these are subsequently removed by shaking devices, such that it can be collected and then one can remove that. And beside the cyclone and hydrocyclone separators are also being used to remove the particulates. Let us look at a typical cyclone separators. Here in this gas with the particle or gas, the particle laden gas are being introduced here in this, which is having a tangential component, and this moves around with a certain vertical force, such that the centrifugal force will be putting, and then particle will be moving toward that, and it will stick to the to this wall because of this vortex which is being formed. Beside this, once it will go, then it will be coming over here and then again moves with a again smaller vortex, and it will be passing through that. During the smaller vortex, the gravitational force which will be acting here, and the particle also will be settled down. There are two ways it can be separated. One is that it will go and stick to the wall of the surface, which is basically due to the higher centrifugal force in the vortex, and other one is due to gravity. And once this particle being there, then you can really remove this particulate, and the gas which is the particle free gases, it can goes out. The efficiency of this cyclone separator is basically around something 95 to 98%, which is quite good. And when the liquid is being used, that weight or the hydrocyclone separator is being used. So, these are the ways by which we can really control the emission from the combustion system. There are several methods which you can also learn, and with this I am coming to the end of these courses, and I have done lot of things in a brief manner just to expose you so that you can learn it better. And with this I will stop over. You might have enjoyed this course, and for other things you can go for advanced books and advanced studies, so that you can really develop a good knowledge about the combustion systems. And once you learn the fundamental of combustion well, you can really design and develop the combustion system with the least amount of emissions, such that we can utilize the energy in an efficient manner. And I hope and wish that you people will be encouraged to learn this subject well and also use in your professional life. Thank you very much.